Lesson 16.12 is called Pythagorean Theorem in Circles. It really piggybacks off of what we just learned. Number 1 says, given circle E with a diameter of CD and a radius of EA, AB is tangent to E at A. So that means this is a tangent line here at A. If EA is 8, so that's a radius, EB is 17, solve for AB. I think I'm going to highlight since this gets so messy. Solve for AB. And then round to the nearest tenth if necessary. Sometimes they'll be cannot be determined, and so you'll have to click on that on Delta Math. So looking at this, I got to figure out, do I have a right triangle? And then can I use, of course, Pythagorean theorem? How do I set up Pythagorean theorem to solve for a missing leg? So we're looking at this triangle right here. I'll highlight the whole thing. So based on my information, do I have a right angle anywhere? Yes, because I have a radius here of EA meeting a tangent line here of AB. So this is my right angle. So from there, I have really a triangle where I know the short leg, I don't know the long leg, but I know the hypotenuse. So I would say x squared plus 8 squared equals 17 squared. We're just going to do 17 squared minus 8 squared. And x squared is 225. Square root of that is 15. So that's what this length is here. Okay, let's try number 2. Given circle E has a diameter of CD and a radius of EA. AB is tangent at A. If AC is 30, EC is 17, solve for AD. Round to the nearest tenth if necessary. All right, so what we got going on here, let me highlight. I've got a right triangle, so this would be a leg, and this would be a leg, and this would be the hypotenuse. Because I know that wherever I have a diameter and an inscribed angle, this is a 90. And so if this is 17, this is also 17 because that's the radius and that's a radius, that would add to make 34. So I've really got a triangle that has a short leg of, I don't know, a long leg of 30 and a hypotenuse of 34. So it would be x squared plus 30 squared equals 34 squared. 34 squared minus 30 squared is 256. Square root of that should be 16. All right, let's try number 3. All the wording is the same. We've got circle E again. We've got a diameter of CD. We've got a radius of EA. We've got a tangent line at A. AC is 28. EA is 16. Solve for CD. Okay, so once you orient yourself with this, I'm not really using EA other than it tells me the radius of the circle from the center to the outside is 16. So that tells me that also E to D is 16, and that means E to C is 16. Anywhere from the center to the outside must be 16. So that would make this D to C side add to be 32. And so I've got a right triangle, let me highlight it, just like I had on number 2, because again I've got a triangle inscribed, or an angle inscribed here, that the hypotenuse is a diameter, and so right angles happening here. So I've got my hypotenuse being 32. I don't know the short leg. Oh, I'm solving for CD. I don't even have to do all that, do I? CD is just the hypotenuse. It's 32. Awesome. So that's all you need to figure out. It's just kind of like a little puzzle. All right, and let's look at number 4. We got circle E with the diameter of CD. All this stuff is the same. CD is 28. So that's a diameter. Solve for AD. Okay, the problem with this one is they don't give us enough information because, yeah, I do know that this is going to be a right angle here, but I don't know either of the legs. I mean, I know that the radius is 14, so I could put that from A to E, but that still does not help me figure out either one of the legs. So this cannot be determined.